Welcome to Derivatives Lesson 8, the chain rule. The rule that in derivatives is the easiest thing to forget and quite possibly the hardest one to hold on to, even though it's chain, because of it has to do with composite functions. And for some reason, you guys just don't like composite functions. Let's get at it before it gets at us. Okay, the first function there, y equals the square root of 4x cubed minus 5. What is the outside function? It is the square root function. What's the inside function? 4x cubed minus 5. Good. Okay, y equals sine of the quantity x squared. The outside function is the sine function, and the inside function is x squared. We have to recognize what the outside functions are and the inside functions, because in order to use a chain rule to make things easier, and the chain rule does make things easier, is to work from the outside in. Alright, sine cubed of 5x squared minus 4x. The outside function, yes, you should recognize that it is the cube function. You're cubing sine. The middle function is sine function, and the inside function is 5x squared minus 4x. So let's go ahead and move on. Okay, up at the top of your notes, it has chain rule first version. Y equals f of g of x. In order to find the derivative y prime, you're going to take f prime of g of x and then multiply that by the derivative of the inside function g of x, g prime of x. Alright, let's finally, we got to your notes where you can actually start drawing something on your notes. What you have here is y equals the quantity 3x minus 2 raised to the 9th power. So what you have here is we're going to take care of the outside function first, which is raising to the 9th power. Y prime equals, go ahead and move the 9 out front as a multiplier. 3x minus 2, subtract 1 from the exponent, 8. Now we're going to multiply that whole result times the derivative of the inside. What is the derivative of 3x minus 2? 3. So now we can clean up and say y prime equals 27 times the expression 3x minus 2 raised to the 8th power. Don't you dare try to distribute that 27 into the 3x minus 2 raised to the 8th power. That 8 has huge power over this, and you just can't distribute through that because of that 8th power. So there's your final derivative for y prime. Alright, let's go ahead and look at the next one. Y equals cosine of x squared. The outside function is cosine. We'll take the derivative of the outside function first. That would be negative sine, and leave that inside function just the way it is. Just like on the previous one, we left that 3x minus 2, we left it alone, times, all of that times, okay, the derivative of the inside function, 2x. Now that 2x is not being multiplied by x squared, it's being multiplied by this negative sine of x squared. So go ahead and clean it up, negative 2x sine of x squared. So y prime of 1 is negative 2 times 1 times the sine of the expression 1 squared. Make sure your calculator is in radians, and y prime of 1 equals negative 1.68294. Alright, let's go ahead and evaluate this one now. Now the outside function is the squaring, because this means cosine x times cosine x, cosine squared x. So first take care of the squaring part first. 2 cosine of x. Now let's take care of the middle function, which is cosine x, negative sine x. And now we'll take the derivative of the inside x times 1. So that would be y prime equals, clean it up, negative 2 sine x cosine x. So y prime of 1 would equal negative 2 times the sine of 1 times the cosine of 1. Make sure your calculator is in radians. And y prime of 1, negative 0.90929. Okay, let's go ahead and move on. Oh, no way. Rational functions, Mr. Manning? Are you serious? Yeah, I am. But with the chain rule, we can make this rational function look actually better. F of x equals 3 times the expression 2x squared plus 3x minus 1 to the negative 1. So, coefficient out front, don't have to mess with that. So, 3 times, okay, move that exponent out front, negative 1 times 2x squared plus 3x minus 1 raised to the negative 2 power, right? Subtracting 1 from negative 1, negative 2. Now multiply that by the derivative of the stuff inside. 4x plus 3. So f prime of x equals negative 3 times 4x plus 3 all over 2x squared plus 3x minus 1. Moved it back down in the denominator to the second power. F prime of x equals negative 12x minus 9 all over 2x squared plus 3x minus 1. Yeah, and we were supposed to find f prime of negative 2. Well, now we can do that. F prime of 2 or negative 2? Negative 2, alright. That equals 24 minus 9 over negative 2. 2 times 4 minus 6 minus 1. 15 over 8 minus 7, 1. F prime of negative 2 equals 15. Alright, let's try this one. Okay, we'll do the quotient rule on this one. So what is the derivative of, we got to take the derivative of the numerator. So first we'll use the chain rule and find out what the derivative of tangent is. Secant squared of 4 minus 5x times the derivative inside, negative 5. Okay, that's the derivative of the numerator times the denominator. This is where some of you messed up on the quiz. Minus the numerator, tangent of 4 minus 5x, times the derivative of the numerator, 3, all over 3x plus 2 quantity squared. Whew. Can we clean it up at all? Yes. We can take care of this stuff right here and move it out front. So negative 15x minus 10 in parentheses times the secant squared of 4 minus 5x minus 3 tangent of 4 minus 5x all over 3x plus 2 quantity squared. And I don't think we want to go any farther than that. Okay, let's move on to our last one, the second version of the chain rule. It's called U substitution. And let's go ahead and flip the page and see what's going on. Alright, what you do is you assign U as a certain function of x, and then express y as some function of u. Alright, let's go ahead and pause for just a second. So, dy dx is going to equal dy du, the derivative of y with respect to u, times the derivative of u with respect to x. So let's go ahead and find out what dy du is right here first. Okay, dy du equals derivative of the numerator 2 times the denominator minus the numerator times the derivative of the denominator, negative 3, all over 2 minus 3u quantity squared. Okay, that's what dy du is. Let's go ahead and clean this up if at all we can. Alright, so you've got 4 minus 6u. Distribute the negative 3, and that would be plus 6u plus 3 all over 2 minus 3u quantity squared. Dy du equals that. Dy du equals 7 over 2 minus 3u quantity squared. And now let's figure out what du dx is. Du dx, the derivative of u with respect to x, is 8x. So dy dx is going to be dy du times d dx du. So 7 times 2 minus 3u quantity squared times 8x. So 56x over 2 minus 3u quantity squared. And now we're going to just substitute u back in. U again was 4x squared minus 5. So dy dx equals 56x 2 minus 3 times, what is that again? 4x squared minus 5. That whole thing raised to the second power. Sometimes that makes things a little bit easier. Alrighty, and you're probably saying that's not clear at all, and that's okay. It's good to get your brain stretched. This will conclude lesson 8 on derivatives, the chain rule. See you tomorrow.